So, to simplify a radical, inside of a radical, what does that mean? If I have the square root of 81, that means I'm looking for two numbers when I can multiply by itself to get 81. And the square root of 81 is 9, right? Because 9 squared is the 81. It cancels it out. A couple items of notation. We used this word last time. The number that goes right here, or right here, or right here, or right here is called the what? Do you remember? Oh. Starts with an I. The index. That number is the index. That's the number that determines how many groups I'm looking for. If there's not a number there, that means I'm looking for groups of 2. Index is a square root. I'm looking for groups of 2. So inside of this 392 is not a perfect square, but inside of it there are perfect squares. So to start, and if you don't remember when you get home how to do this, can't write in white. If you don't remember when you get home how to do this, there's a step right there. Okay? We start by making a factor tree. So what goes into 392? 2. Now, we don't necessarily have to get it down to its primes. We just need to get it down to its groups. So if 4 works, we can use 4. 4 times what?
Oh, I thought you were just leaving 4. And I was like, that is not...
You can leave the 4. What goes into 46? This 4? 99. No, it doesn't. Darn it. So let's break this down. 2 times 2. 2 times 20. Did I screw up somewhere? What's the 196 divided by 4?
49.
What?
49.
Yeah, there it is. There it is. Okay, 49. So then we break down the 49 to be 7 and 7. And because the index is 2, so 1, we make a factor tree. 2, we find groups of the same number. So I've got a group of 2 here, a group of 2 here, and then a loner here. Okay, is that all right? Yeah. All right. Now, how do you know what goes out of the radical, what stays in the radical? Groups go out, loners stay in, kind of like Friday night. Okay, good, you got it. Okay, so I told that joke 4 times last year, and then this year I tell it one more time, and this girl's like, oh, I get it. I'm like, great. No offense.
So sad.
Right? So rude. Please don't take offense. I'm mostly kidding. So these 2 numbers together, when they come out, you multiply them. Okay, they come out and you multiply them. And the loner 2 stays in. So how do I rewrite my final answer? 14 square root 2. We do this for several reasons. In the future, we're going to have square roots in fraction form, and we should be able to reduce fractions. So you have to be able to simplify a square root in order to reduce fractions later. Before we had the technology that we had, reducing things made it easier to multiply, made it easier to divide, which was kind of the point then. Now we just do it so our numbers look pretty and smaller and nicer. That's kind of the why here. So let's do that again. On part B, we're looking for groups of what this time? The index is 3, so we have to find groups of 3. So this index right here matters. Okay, what goes into 132? 2. Do you know the rules? Here, let me teach you the rules really quick. How do you know a number is divisible by 2?
Because there's an even number.
It's even. Do you know the rule for 3?
Add to the number that's
close. Digits, no D. Right? When you add the digits together, so in this case 1, 3, 2, added together is 6. Does 3 go into 6?
Yes.
If the sum is divisible by 3, then I know that number is 2. So 132 is divisible by 3 because 1, 3, and 2 add together to be 6. 3 goes into 6. Do you know the rule for 4? The rule for 4 is if the last 2 digits are divisible by 4, the whole number is. So if you had a number like, I don't care about any of that. I care about the 20. Does 4 go into 20?
Yeah.
Yes, so 4 goes into the entire thing. Do you guys know the rule for 5? You better.
It ends in a 5 or 0. Yeah.
Okay. Do you know the rule for 6? No. If 2 and 3 both work, then 6 does too. I don't know the rule for 7 if there is one. There is a rule for 8. 8's like 4, but you gotta look at the last 3 digits, and quite honestly, I don't know if 8 goes into that, so I never will actually do that one, but I don't use the 8 rule because it's too complicated. What about 9?
Wait, what's the rule for 3? I don't understand
For 3?
that. Yeah. No, I mean for 6. I mean, yeah, 6.
6. If 2 and 3 both work, then 6 does too.
Oh, okay.
Because that makes sense, right? Because 2 works and 3 works, and you multiply them, and then they both will. 9 and 3 are very similar. You add the digits together. But this time the sum has to be divisible by what would you guess? 9. So on that one right there, when we added those, we got 6. Does 9 work? Nope. And then the last one, 10. It has to end in. So not critical information. You could sit around on your calculator and say divide 7, divide 8, divide 9, divide 10, but that's going to take some time, right? If you know the quick rules, then we can like keep going. So on 132, it's divisible by what?
6.
6, sure. And 6 times what? I don't trust myself to multiply or divide in my head anymore. 6 times 22?
Yeah.
Okay, and then here is 2 and 3. Here is 2 and 11. We're looking for groups of what this time? 3. Are there groups of 3?
No.
No, so what happens? That means my answer is the problem, and you can be irritated for making you do all of that work and nothing actually changed. I have no groups of 3, so my answer is the problem. That sucks. Moving
Why
on.
is it
What's
1?
wrong with the worst?
Because nothing broke down to groups of 3, so I can't pull anything out, which means everything's left in.
So you just multiply everything together?
Yeah, or you just say nothing came out, my answer and the problem are the same thing.
Okay, so you, oh.
Right? Yeah, stupid
Okay.
teacher made me do a problem that didn't actually work. I hate when you have these like complicated, you may not have gotten to like crazy complicated like algebra things, and then all of a sudden you're like x equals 0, and you're like, oh, that worked for x equals 0. Okay, the next one, we're looking for groups of what? 2. So 63 is what times what?
3.
9 times 7. And it doesn't matter if you would have done 3 and 21 or 9 times 7, like they both work. What about 9? 3 and 3. Groups go out. Loners. You're going to remember, and that's a joke. Okay, so how do I rewrite this? My group goes out, my 7 stays in, nothing else I can do. Okay, let me show you a giant mistake people make when they're doing factor trees. And I know that you know this, but just be careful. So I'm breaking down 100. Is it 50 and 50? No. Okay, so that happens all the time. What mistake did they make? They added instead of multiplied, right? So this should be a 50 times 2. So if you're getting like outrageous numbers, it's probably because your factor tree is kind of messed up. So careful there. All right. Part D. Now this one's very similar. What is this 2 out front? It's 2 just hanging out. It's connected to the square root by a multiply. So you do everything the same. Ignore the 2 for now. Let's break down the 112. On your own, will you break down the 112, decide what comes out, decide what stays in. And then we'll discuss what happens with that 2 in front. I'm going to take attendance. I don't even think I did last class.
Make sure you pass the recording.
Right? Oh, thank you. I probably wouldn't have. All right, let's break it. Sorry, that took a long time. So let's look at this 112. What times what is 112? Say it again. 28. Okay. So this brings up a good point. On 28, I could do 4 and 7. Do I have to break the 4s down into 2s? Or could I say, group right here? I can group it even though those aren't prime. Is that okay? Because what would happen otherwise? I would break this down into 2 2s, and I'd break this down into 2 2s, and I'd say group, group, and then what would I do with those groups? I'd turn them into a 4 anyway. So it doesn't matter if you group 4s or if you group 2s. The final answer is together they're going to be 4s anyway. So the 4, does it stay out or does it go in? 4 goes out, 7 stays in. Now as the 4 comes out, what do you think is going to happen between the 4 and the 2?
Multiply.
Right. So 4 times 2 is 8 square root of loner 7. Square root 7. Let's try one more. Square root of 225. Oh, sorry, Evan, did you have a...
So when there's more than one left inside, do you multiply those together or just leave them?
Yep. Okay, 225. What times what is 2? It's 15, right? 15 times 15. It's a perfect square. So what happens when you find a group and there are no loners? Well, the group's going to come out and mesh with the 6. 6 times 15 is 90. There are no loners, so your answer is just 90. So if the entire group comes out, the radical goes away. All right, any questions with this part before we throw in variables? This is like the store part. You already knew how to do this part. Okay, so now we're going to throw in variables. Before we do so, when you take the square root of a number, if I were taking the square root of 25 or the square root of 100 or the square root of 90, no, not 90, oh, 90, it's just not pretty. If you take the square root of a number, it will always be positive. So variables change things a little bit because a variable can be positive or negative. So there's going to be a rule that comes with variables as they come out. Sometimes it's necessary to make sure your answers are only positive. And I'm going to show you kind of the rule in a minute. So let's look at this really quick. Let's break down the 128. What times what is 128? Anybody? 8 and 16. And what's 16? 8 and 2. And is it okay with you if I don't break those 8s down, if I group them already? Okay, so let's start by looking at that. 8 goes out. I'm going to leave a space because there's a variable we haven't done yet. 2 stays in. Now I've got 4 x's. If this helps you, you can list the x's. I'm looking for groups of 2 still. There's one group of 2. There's 2 groups of 2. They will both come out. Now how could I rewrite this as a final answer? It's going to be 8x squared square root 2. And I'm not going to tell you the rule about variables for just a minute. I'm going to try a couple. Okay, so temporarily this is our final answer, and then we'll come back and look at it again. I'm going to skip part G for just a second. Let's look at part H. There we go. Let's look at part H. On part H, I've got the 12, which is 4 and 3, 2 and 2. The group of 2's come out. The loner 3 stays in. So what am I going to write on the outside? Group of 2's combined with that 2 to make a what? A 4. And then the loner 3 stays in. I still have the variables to look at. I'm looking for groups of 2. So I've got how many groups of 2? 1 comes out, and then my loner stays in. So temporarily, this is our final answer. We've seen 2 different examples using variables. What questions do you have so far? Nothing so far? Okay, then just kidding. I was going to say on your own, let's try something. Now, like we just mentioned, this number has to be positive because square roots are always positive. Cube roots don't have to be positive. We don't care about those. But square roots do. Just because on a cube root, you can get a negative times a negative times a negative to also equal a negative, right? 3 negatives, is it still negative? So yeah, it's okay to have negatives here. But can you get 2 negatives to make a negative? No, because a negative times a negative is a positive. So negatives can't happen here. So the 8 will always be positive because it's just an 8, right? The 4, well, let me get that for me. The 4 will always be positive because it's just a 4. Well, let's look at the variables. Will x squared always be positive? Think about that. Will x squared always be positive? If you plug in a number, say plug in -2, and you square -2. What's -2 squared?
4.
-2 times a -2 is a +4. So the squared right here is always positive. This is our final answer. This one's done. But right here, will x always be positive? If you plugged in a -2, is this positive now? Is -2 positive? No. So we need to do something to the x to make sure it stays positive, and those are called absolute values. So I'm going to add an absolute value around the x on that problem so that I ensure that it's positive.
And is that the finished problem?
That is now the final answer. Now, if you don't understand on the first try, I get it. We're going to try a bunch more until you do. But something to note, if we're going to start writing our rule, we only care about absolute values if there is an even index. So on part G, don't care about it. On part K, I don't care about absolute values at all. If there's an even index, I have to watch for absolute values. All right, now there's only two differences between here. This one needed absolute values. This one did not. So let's see if we can do part I and finalize the last part of our rule. Okay, on part I, let's start by looking at the 175. What times what is 175?
25 and 7.
25 and 7. And then 25 is 5 and 5. Okay, so this 5 will come out, join with the 3 and make a what?
15.
A 15. The 7 stays in. I left a space because we have variables. Now looking at the x's. I've got 3 x's. My group will go out. My loner stays in. Is that okay? And what about my y's? How many groups do I have here? My group goes out, and that takes care of everything. Now, I don't care about the variable inside the radical. Because it's a radical, I know it has to be positive because we're talking about a real number. If that variable inside the radical is negative, then we're doing imaginaries, and that's not right now. So all we care about are the x and the y on the outside of the radical. Could x right there be negative?
Yes.
Yeah. What about the y's?
Yeah.
So x could be anything. So we have to put an absolute value on it to make sure it's always positive. And what about y? Y can be anything. So we have to put the absolute value on it. This, by the way, is the hardest part of today. So don't zone out on me. If you're like starting to drift, then just stand up and go get a drink or something and then come back.
Would the x be x squared?
Nope, because there's only one group that comes out. So as they break out of the radical, the squared goes away. It's like it cancels.
Okay, so last time, since there's 2 groups, it made the x.
That's why it made the x squared, because
Okay.
there was 2 groups of them. Yep. This is your final answer. So what do these have in common? Let me go back to my full. What do these have in common? Because they both needed absolute values that this one doesn't have in common. Lucely?
Wait, I just have a question.
Yeah.
So by even index, you just mean an even number as the index, right?
Yeah. So this number right here. So that could be
Oh,
that could be a
okay.
4, that could be a 6, but if it's an even index, then I have to worry about absolute values.
So if it was cubed?
If it was cubed, yeah, on this one we don't care about them at all.
Okay.
Okay. So if it has an even index, and then what's the difference between this one and this one? Or what's the difference between this one and this one?
Squared.
This one is squared, this one is not, right? So, is there an example? There's not. Let's pretend like this is just a regular square root. Looking at part K, we're changing it to a regular square root. What's the square root of 64? 8. And then x to the 6th power. How many groups of x's do I have? 3. Now, can a negative times a negative times a negative equal a positive? Because that's 3, right, cubed. So can a negative times a negative times a negative equal a positive? Is that possible? No. So this one needs an absolute value.
Oh, alright.
Okay, so what's the rule? It has to have an even index in order for you to care about absolute value or not.
So you're supposed to write
What?
So you're supposed to write that? Okay.
And this has to have an odd power. So if there's an even index, and an odd exponent. So the rule is even odd. And as we practice more and more, I'm hoping that the rule kind of comes. So before you ask any questions, because I'm hoping that you have some, will you try part J? Sometimes if you're not sure if you have questions and if you can do it, just try and one helps. So try part J. See if you can figure out if it needs absolute values or not, because you've never done this part before, right? Even, odd. And please don't be afraid to ask questions if you have them. I'm a caring, understanding person, so yes. When you did it with the cube, because we changed it so it was a square root. So that would be the answer if it was a cube root. Yeah. Yep. So we just changed it. Just, I wanted to point out that if it was a 3 right here, then it still needed the absolute value, which is why I changed it. Okay, part J. Thanks, Phil. Carson, give me, what was your question? Okay. Okay, let's look at part J. Looking at the 24. 24 is 4 and 6, and then 2, 2, 2, 3. That's kind of fast, but are we okay with that? Okay, the group of 2's go out. The loners stay in. These 2 come out with a 6 to form a what? 12. A 12. The loners get so excited that they're not alone. They multiply. Okay, that's a joke. Okay, so 2 and 3 multiply. Going back to the storks. Okay, never mind. Okay, so far, are we okay with the numbers?
Yes.
Okay, now looking at the x's. I've got 4 x's. How many groups of x's are there? 2. And if it helps you to write out the x's, you can. If you can just look at the 4 and know that there's 2 groups. Now when there's 2 groups, how do I write that?
Squared.
X squared. And then what about the y? Again, if you just know the answer, write it. If not, write them out. Group them. How many y's come out? 1. So far so good. Now we have to decide if there's absolute values. And I know that we're checking because that index is even, right? So, will x squared ever be negative? No. No, so that one doesn't need it. What about the y?
Yeah.
Yes, so the absolute values come all around the y. And that is your final answer. Raise your hand if you got it.
I'm kind of confused on the y.
On the y? What part on the y?
Like how, so when you get the y, why would it be yeah.
Why is it absolute values? Because y's could be negative. That y could be negative because it doesn't have a power that's going to force it to be positive. So we have to force it to be positive by putting the absolute values. We don't care about this one because even if I plugged in -2, that's going to be positive because of the negative and the negative. Okay? All right, we skipped G. Any other questions? Carson, did I answer yours as we kind of did it? Any other questions before we move on? Okay, look at part G. This time we're looking for groups of 3. So when we break the 72, I'm going to erase everything because it's looking really cluttery. Is that okay? Okay, when we break down the 72, I have 36 and 2, and then I have 2 and 18. Is that right? Did I screw up somewhere? 2 and 9, and then 3 and 3. This time I'm looking for groups of how many? Groups of 3. So those 3 2's will come out and they will form a 2. but my 9, the 3 and the 3, have to stay in. Is that okay? Okay, then I've got 4 X's. How many groups of 3 come out there? 1 group of 3, 1 loner X. So 1 group of 3 stays out, 1 group of 3 stays in. Now, does this one need the absolute value? I erased my rules. What's the very first rule? It has to have an even index. Does this one have an even index?
No.
No, so I'm done. I don't even need to consider absolute values because it is possible to have an even number inside of an, oh, except for I forgot a little 3. When you write the 3, please make sure it's small and kind of inside that radical arch. If it looks like this, it kind of looks like that should be 6x square root 9x. So this is not okay. Make it kind of small. All right, was that the last example on our real number system? Yes, so I'm going to pause. All right, now we're going to do the exact same thing, but we're going to do them with complex numbers. The difference, the complex number system assumes that there's a negative inside, right? Right? So it is not necessary to put absolute values because there can be a negative inside of there. It assumes that it's going to be a negative anyway. So we're going to do the exact same thing. The only difference is we're ignoring absolute values completely because negative numbers can be inside the radical if you're talking about imaginary, and my answer will have an I on it. So let's ignore the negative for a minute. Let's break up the 20. 20 is
10 times 2.
10 and 2. 10 is 2 and 5. If you get your factor tree wrong, your answer will be wrong, right? So you got to be careful. Now, on the test, if you get your factor tree wrong, and I can see that you put 5 and 5 here rather than 5 and 2, and so your answer is kind of messed up a little bit, I won't dock you all the points because I can see where your mistake was. That's why showing your work is critical. Now, looking at this, the 2 comes out, the 5 stays in. Now, notation, this is where the negative will come in. The 2 goes out, the 5 stays in, and because it's a negative, the answer is imaginary, and you put the little I right here. So the imaginary goes between the 2 and the radical. And notice on all of these, are there any cube roots?
Yeah.
The index on all of these is what?
2.
Even, right? You won't get imaginaries if you have an odd index. Only even index, so these are only square roots. Okay, let's look at 80. 80 is what times what?
8 times 4.
8 and 10. And then 2 and 5. 2 and 4. Now when I do my factor tree, if you can kind of strategically plan it so that like your groups are close to each other. So I knew that there's going to be a lot of 2's in my 8, which is why I said 2 times 5 rather than 5 times 2. That way I strategically had my 2's together. It's not essential, but it's a way that you can maybe eliminate an error later. Okay, loner 5. These 2 come out and make a what? They come out combined to make a 4. Because it's negative, it's imaginary, and the 5 stays in. So it's really the same thing, right? We used to spend an entire day doing the first part, and then a couple months later spend an entire day doing this part, but it doesn't seem necessary because it's the same thing, just these are imaginary numbers, the other ones are real numbers.
What's this part that was supposed to be a totally different lesson we just did?
Sort of, yeah. All of the imaginary stuff was supposed to be one day, so we introduced it last time. We're working on it a little bit more this time, and then next time we'll do it a little bit more. So, okay, C, try it on your own. Break down the 120, look for the imaginary. It's not wrong if you put the I at the end. It is wrong if you put the I on the inside. Okay, if you use your phone as a calculator, they're on your desk, it's not a giant deal. I'm not okay if you use your phone as a texting device right now. Okay, 120 is, part D is actually on last time's lesson. So as soon as you got that, then there's a whole chunk from last time that you're like, oh, done, I can do it. Okay, sorry, 10 and 12. And 5 and 2, and 2 and 6, and 2 and 3. We're looking for groups of 2. So this is a group of 2, and then there's lots of loners. Those loners all do what? They multiply together. So 5 times 2 is 10, times 3 is 30. And where should I put my loners? Inside or outside? Loners stay in. Okay, what comes out? The 2 comes out, and the I comes out. You have an imaginary answer for these problems. And when we start looking at graphs and imaginary solutions, there's a certain trait to all imaginary solutions. So we introduce it now so that we can talk about imaginaries later and it's not a total foreign concept. Okay, part D. Now this one's nice because 16 is a perfect square, right? So you have your group of 4s. What happens if the entire radical goes away? If there's no loners, radical's gone, right? So it's 4i. Yeah, no radical. Can I get a 5, 4, 3, 2, 1? How well do you feel like you understand this based on just the numbers, no variables with the imaginaries?
Wait, raise your hand of what?
Like 5, 4, 3, 2, 1. If you don't want to like show the whole world that it's a 2, you can kind of like do a close. It's fine. I just want to hear. See, okay. Okay, let's do part E. What times what is 1,000? 100 times 10. And 100 is 10 times 10. Oh, what did I just do? 10 times 10. And do I have to keep breaking up those 10s? I've got a group of 10. If you need to break this one up, you can, but they're both loners. What goes out, what stays in? And if it helps to remember my Friday night inappropriate loner joke, then remember my Friday night inappropriate loner joke. So groups go out, loners stay in, just like Friday night. Groups go out, loners stay in. When they stay in together. And how do I finish this off? Just don't forget that this is an imaginary solution, so imaginary answer. Okay, try F, all on your own. F is even more out. Try part F. I'm going to come around and look, and then once you're done with F, you can do 4 more problems on your homework. So you should be able to look at 19 through 22. I need 30 of them. Good. Sorry, I was going to come around and look. Have your notes handy so I can check your part F and help you out with F. Finish off F for me. Good. Good. Once you're done with that, look at 19 through 22 on your homework and anything else that you haven't quite finished. Good. We're only looking at F. You don't have to move on from there. Good. 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 Yeah, yep. Oh, wait, no, just kidding, because you're looking for groups. Those groups of 2 then. Good. Yeah. Try to get really quick. It's 25 times 2. So this should be 5i squared 2. Yes, put it in, and then put this on my computer so I can Okay, so, yeah. Today was kind of a crazy day with the lockdown, and my 5-year-old like, Mom, I'm scared, so, and then I'm like, stay in there. I gotta teach. And then she's like, I've gotta go to the bathroom. Let's go. Like, what are you supposed to go?
This one?
This is why you don't bring your kids to work. And I normally don't. This is all nice. Good. James, did you finish your notes? Hold on. I checked everybody's. I don't think I checked. Okay, cool. I think you got it. Let's just show it really quick because it's not super fast. 50 is 25 times 2, and then 5 and 5. I'm looking for groups of 2. So the 5 comes out, the negative comes out, square root 2, which is what I saw everybody get. Okay, let's look at it with the variables again. Again, the only difference is i's. We don't even have to worry about absolute values. So 25 is 5 times 5. That group comes out. Now I'm looking at the x's. There's a group of x's. That comes out. Notice I left a little space on purpose. And then the y's, how many y's do I have? I have one group, I have two groups. So you could first write it like this, right? But if I were to write that in the most simplest form, it would be 5xy squared. Now, the negative comes out to be imaginary. Notation says the imaginary kind of hugs close to the number. So it's 5ixy squared. Whew. 5ixy squared. That is ugly. Now, if you put it off on the end, it's not wrong. It just doesn't look right. To me, it probably looks just fine to you. So I should hug the number. Okay, let's look at part H. Sorry, with part G, the radical went away because everything came out.
Yeah.
Okay, on part H, the 60. 60 is 10 and 6, 2 and 5, 2 and 3. Sometimes I like to have a math party at the board by myself and I completely ignored you all. Are we good? I was just in the middle of math party, alone on the board. Okay. The 2 comes out. The 15 stays in because the 5 and the 3 are loners together. Now what about the x? X comes out, x stays in. Stays in, there's only one. What about the y? 1 goes out, 1 stays in. Extend that a little bit longer. Does the y need an absolute value?
No.
No, because the answer is imaginary, so who cares if it's negative? Now, because of the negative, I'm going to hug that imaginary right next to the 2. 2iy square root 15xy. This is why you all grade your own, and I don't have to say these every day. 2iy square root 15xy. That sounds terrible. Almost sounds like child abuse. Not quite. I'm just kidding. Fine.
So does the I always have to be right after the 2?
That's where I prefer it. Like, no, I was kidding. Oh, I love this stuff. I could do it every day. 27 is what times what? 9 is 3. And 9 is? Oh my gosh, class is over. I'm sorry. Is your homework almost done though?
Yeah, I got
3 goes out. 3 stays in. What about the 10? You could write all of them. And then you could group them. Just because I said class is almost out, don't pack up. We're not quite there. Almost. How many groups of x's come out? X to the 5th.
comes up to
We're almost there. What about the y? 4, 5, 6, 7. How many groups of y come out? You have to kind of think of the dividing and then the remainder, right? Remainder 1. 3 groups. Do we need absolute values?
No.
No. So the answer is 3. I, x to the 5th, y to the 3rd, square root 3y. Woo! That's all. Thanks for watching. Peace out. Come again.